Okay, today we're looking at section 4.6 in your textbook. It's on page 194. We're talking about negative and zero exponents. So you guys have become familiar with, I hope you've become familiar with some of the exponent laws when we have the same base. And we have, so if we're multiplying two numbers with the same base, we do what with the exponents, yeah?
Oh, you have to add the ones together?
Yeah, we add the exponents together. So this becomes 2 plus 3 and the exponent of 5. So that's called exponent law. So we've covered a bit of that already. What we're dealing now with in particular is negative and zero exponents. So we know when we divide powers, in this case we're dividing powers with the same base. I'm just using a as a random variable. We need to minus the exponents. So that'll give us a power with a negative exponent. Okay? So this is what we're going to be talking about today. What do you do when you get a negative exponent? Typically in math, we don't want to leave any answers with a negative exponent. Okay? We want to always make our exponents positive. Okay? So that's what we're going to be talking about today. So when a non-zero base is raised to a negative exponent, the result is the reciprocal of the base raised to the positive of the exponent. So it's a bit of a mouthful to read, but basically what you do when you have a base of 2 to the exponent of negative 3, you flip the 2, so it becomes 1/2, and you raise it to the exponent, the positive exponent. Okay, so in actuality, I should have written that like this. So it's actually 1/2 to the exponent of positive 3. Okay? I want you to be aware that the original way I wrote it originally, we can now simplify that to 1 to the exponent of 3 over 2 to the exponent of 3. And of course, 1 to the exponent of 3 is just 1, so over 2 to the exponent of 3. But I want to make sure that you don't just put the the exponent to the denominator. The exponent lies both with the numerator and the denominator. So as a better example, if we had a fraction, say 2/3 to the exponent of negative 3, now we're going to take the reciprocal of 2/3. So you're flipping the base, 3 over 2, and now the exponent becomes positive. Okay? And then you can further simplify that to 3 cubed over 2 cubed, or 27 over 8. Okay? Remember when we have brackets and we have an exponent, the exponent applies both to the numerator as well as to the denominator. When it's a whole number and you flip it, the numerator is always a 1, and 1 to any power is still 1. That's why originally when I showed you it looked just like that, because we know any power to the exponent of 1 is just 1 over, and then applying that exponent to the denominator. Matthew?
Should we evaluate 2 afterwards?
Yeah, depending on the question, it may tell you just leave the answer with exponents, or it may tell you to evaluate. Okay, it should specify that. All right, so that's the first step. So pretty straightforward. If you have an exponent that's negative, to get rid of the negative sign, you flip it and change the sign of the exponent. Okay, if it's a whole number, obviously, whole numbers are all over 1, so that's where that 1 comes in at the numerator. The second point we're covering today. When a non-zero number is raised to the exponent 0, the result is 1. All right, so the example here, we're kind of reasoning backwards, but if we know 1 is equal to 100 over 100, any number divided by itself is 1, we know 100 is just the same as 10 to the exponent of 2, or 10 times 10, so I hope you can follow this logic. Well, 10 to the 2, we know from exponent law, is we minus the exponents when we're dividing powers. So 10 to the 2 is 2 minus 2. 10 to the exponent of 2 over 10 to the exponent of 2 is 10 to the exponent of 2 minus 2, which is 10 to the exponent of 0. Okay? And a simpler example, if you just think about it as 5 divided by 5, we know is 1, of course. Okay, but we also know that 5 to no exponent is the same as 5 to the exponent of 1, right? When we don't show an exponent there. So really what we're doing then is we're saying 5, 1, minus 1 with exponent law, right? We minus the exponents. So that's going to be equal to 5, the exponent of 0, which is 1. Any questions there? Okay, so anytime there's an exponent of 0, the result is 1. Okay, even if it's a negative number, if we have negative 2 to the exponent of 0, this is going to be equal to 1. Okay? Be careful though, if we have this question, negative 2 to the exponent of 0, this is negative 1. Okay? Make sure you understand the difference between these two. Because this is in brackets now, it's including the negative 2 in that exponent power. Okay? Whereas this is not. This is negative, stays on the outside. The 2 is only to the exponent, so that becomes negative 1. Any questions about this? Can be confusing. Anybody confused there? Yeah? Any?
What if the base is 0?
If the base is 0, it's 0. Okay? That's why. If you have a base to the exponent of 100, this is 0. Base to the exponent of 0, this is 0. Okay? Alright? You don't, the law doesn't apply for 0. If you have nothing, you have nothing. Okay? Any other questions? Okay, we're going to do some quick examples, and then I'll let you guys do the homework. So this is on page 197. Okay, so who's going to help me out with the first one? Oh, Sebastian. What do you think? So what's this going to be equal to?
A quarter.
Good, a quarter. So what Sebastian did was, 4 is just 4 over 1. He flipped the base to 1 over 4, and he changed the exponent to positive. So it's 1 over 4 with a positive 1, which is the same as just 1 over 4. Excellent. All right, Diego, try this one. A to the exponent of 0? 1, good. Very easy. Excellent. Next one, Ace. Negative 2 to the exponent of negative 3. Go step by step. So what's the first step? Whenever you see a negative exponent, you're going to do what to the base?
It'd be 1 over 2.
Good. Not 1 over 2, but 1 over?
Negative.
Negative 2, because it's in brackets. Okay, and then all of that to the exponent of?
3.
Good, positive 3. Okay, and now that positive 3 exponent applies both to the numerator. 1 to the exponent of 3 is just 1. And now negative 2 to the exponent of 3. Finally, we can finish that off. 1 over negative 8. Okay? Any questions with that one? No? Okay, next one. Devono? The first step, when we see a negative exponent, we do what to the base?
We flip it, so 3 over 2.
Excellent. 3 over 2, good.
Bracket,
Yeah.
2.
Good, positive 2, yeah. And now that's going to be equal to? What do we do? What happens with this square now?
No.
Yeah, we're going to do what with the numerator, Kyle?
It's 3 squared over 2 squared.
Right, 3
Oh.
squared. You square both the numerator and the denominator, okay, Nicholas? So
So
3 squared is?
9.
Good. And 2 squared?
4.
Excellent. All right, 9 over 4. All right, and the last one. 0 to the exponent of negative 2. Yeah, this one's interesting because there is a negative exponent, so if we were to flip this, we know 0, any number over nothing is over 1, so this is 1 over 0 to the exponent of positive 2. And as we know, 1 over 0, on a graph it would be a vertical line if we did rise over run, but it's undefined. Alright? think about it, it's almost like infinity. How many times does nothing go into something? Well, it's going to be,
That's
you know, there's going to be a lot, right?
right. Would it be the first one, so maybe.
Yeah, it's undefined. You can kind of argue both ways, right? Because as you approach 0, so as this is a really, really small number, Luigi, right? This becomes a really large number, right? That makes sense? So you're right. You could argue both ways. That's why it's undefined. But if you put a number in really, really close to 0, it's going to be a really, really large number. This would be about, 1, 2, 3, 1, 2. This would be about 1 billion.
But it's not a number close to 0, it's just 0.
Right, you're right. That's why it's undefined. Yeah. Okay. That's it for the lesson. Actually, sorry, there is another example. Let's do example 2 in the book. Let's go over here. Okay, we're looking at example 2. This is carbon 14. It's a radioactive element that decays to 1/2 or 2 to the negative 1 of its original amount after every 5,700 years. Determine the remaining mass of 10 grams of carbon 14 after 11,400 years. All right, so we know for each 5,700 years, the original mass decreases by a factor of 1/2, or 2 to the negative 1. Okay, so that's going to be our sort of base value, if you think about it that way. So we want to find out how many 5,700 year periods of time are in 11,400 years. So if we do 11,400 years, we can divide it by 5,700 years. That'll tell us how many 5,700 years go into 11,400 years. And we get 2. So there's 2 time periods. Okay, so if we start off with a mass of 10 grams, and we're decaying by 1/2 every 5,700 years, and there's 2 5,700 year periods, so we're going to multiply it by 1/2 times 1/2. We're going to realize then that we get 2.5 grams. Okay, so the remaining mass after 11,400 is 2.5 grams if we started with 10 grams. All right, the second part says after 28,500 years, so we would take 28,500 divided by 5,700. That will give us the number of periods, which is 4. Now we're going to multiply that 1/2 times 4. So in other words, it's 1/2 to the exponent of 4 times 10. Yeah?
Is it equal to 5?
No, 10 times 1/2 is 5, times another 1/2 is 2.5.
No, but I mean,
Next one.
like 28,500 over 5,700, isn't it equal to 5?
Is it? You can do the division on your calculator?
Should be 5.
Then it goes
I can do it in my head.
5 times 25. 5 times 5 is 25.
5 times 4 is.
Somebody use a calculator. What do you
Oh,
get?
sorry,
Yeah,
5 times
it's
7 is.
It's 5?
Yeah.
Oh, that's weird. The book has 4. Hmm. 5,700 times 4.
That'll be the description, right?
Yeah, the book's wrong. All right, 5. There we go. Good job, you found a mistake in the book. There we go, so now 1/2 to the exponent of 5 times 10. We'll get a different answer then. So what's the answer? So we do that on the calculator? Only one guy with the calculator? Kyle? .0 32.
Where's
What is it?
79?
1/2 to the exponent of 5 was 1/32 times 10 is equal to
Okay.
10 divided by 32. It's going to be around 1/3. It's going to be around point, so 0.32. Is that right?
I got
Yeah.
5 over 16.
Yeah. Move what? Oh, this?
It should be so.
You got 5 over 16?
Yeah.
What's that equal to in decimal?
Uh.
0.3125.
Okay, 0.3125.
Yes, sir.
Alright.
Because you didn't go to the lowest thing, so it'd be 5 over 16.
Doesn't matter, it'd be the same decimal.
Yeah, it should be.
It is.
It is.
Yeah.
So what did you guys get?
0.3125.
3125. Okay. Alright, so that's the answer for Graham. Any questions about this type of problem? Okay, that's it. We can finish the